Hello and welcome to Tensile Ground Coffee. A few minutes on ground engineering to enjoy while having your coffee. Looks good, doesn't it? Apple pie, fresh out the oven. Now, if you're like me, you like to have something with your apple pie. Maybe some vanilla ice cream, but in the winter, I say you can't beat a bit of custard. That's what I'm making here. What's that got to do with ground engineering? Well, custard powder is a granular material. Rather like soil. Soil is a granular material. So there's the powder there. And there are many granular materials in the kitchen, such as rice, sugar, salt, pasta, cereals, beans, peas. A good example is these. These are chickpeas, rather like a fine gravel. And this is the main ingredient of hummus dip. And who doesn't like hummus? Come on. Now, granular materials behave in an unusual way. They can transition from liquid to solid behavior. So in a relatively loose state, they can be poured and flow like a liquid, like this. But once they settle into a relatively dense arrangement and they form a skeleton with contacts between them, then they behave more like a solid. So it can support the weight of objects such as that. You can also demonstrate the transition from solid to liquid behavior if I fill this plastic bottle with the chickpeas. So first of all, you will notice that the opening of the bottle, how big is it? It's about 3 times the diameter of the chickpeas. So if I fill this bottle with the chickpeas, you would expect, if I turned it upside down, that there's plenty of room for the chickpeas to flow out. So we'll see that that's not quite the case. So I'm going to fill this up. This will take a little while, so we'll probably cut this, won't we, Brian? Yeah. There we go, that's just about full. So let's turn this upside down and see what happens. A few of the chickpeas drop out, but then we get a phenomenon called jamming. So you see that the particles actually arch across the opening to the extent that they will support the weight of all those chickpeas above and transfer that load to the sides through this arch effect. And that's something that soil does. We often talk about the phenomenon of soil arching, that is its ability to span around voids and soft spots in the ground. Now, if we make a disturbance to this, it may start to flow again, and then it jams again. Now, imagine this was a silo, storing a material such as grain, and you wanted to extract the material. Clearly, this jamming would be a problem, and there have been many studies into the jamming of silos over openings. And those studies show that this jamming is a possibility at any opening up to about 6 times the diameter of the grain that's within here. Bigger than 6 times, and then jamming is not normally a problem. But in geotechnical engineering, jamming is a good thing. We want a good solid arrangement of the particles. So when we look at geogrid, we've done a lot of studies into the relative size of soil particles and geogrid apertures so that we get this sort of jamming effect. And that's good because it locks the particles, prevents their movement, and that's how we get mechanical stabilization of soils around the geogrid. So you see this problem is actually quite relevant to soil mechanics and the use of geogrids. Right, let's go back to the custard that we're making for this apple pie. Now, another strange effect that you might have noticed if you've ever mixed custard, the paste is like a liquid, quite a viscous liquid. But if you put a spoon through that liquid, you get a lot of resistance and it behaves like a solid when you're trying to push the spoon through it. So the reason that happens is similar to the effect of stepping on the wet sand on the beach that we saw before. You've got particles here, particles of corn flour actually, in the custard powder that are in a dense arrangement in the liquid. When we try to shear it, those particles have to move apart. That draws water into the voids. But if there's not enough water available, as in this case, that generates suction or negative pore pressure that holds the particles together and makes them behave like a solid. To such an extent that I might be able to actually pick up this liquid, roll it into a ball, and actually mix the custard that way. So I can actually form a ball, a solid ball, as long as I keep deforming it and I keep shearing it. But of course, if I stop, then it turns back into a liquid and flows. Okay? Isn't that amazing? So 2 simple experiments that you can use to demonstrate the unusual behavior of granular materials in the kitchen. Okay, that's all for this episode of Tensile Ground Coffee. I think I'm going to start again on this custard. Thanks for watching and see you next time.